Hey ladies and gentlemen, this is Miss Humbert here. So today we're going to be doing Unit 7, Note 2. So we're going to be talking about fundamental counting principle and using it with different arrangements. So it's just going to be kind of a play off of what you did on the previous note sheet. So let's kind of take a look. So counting arrangements. So for this first one, Student Council has a president, vice president, treasurer, and secretary. For the School Assembly, they're all required to sit up in a row. So if we're sitting up in a row, that means we have 4 spots. And the order matters of where they sit in a row. So let's take a look at the first spot. Well, when we pick a person to sit in the first spot, we have 4 different choices. Well, once we pick a person to sit in the first spot, now we only have 3 choices for the second spot, 2 choices for the next spot, and 1 choice for the last spot. So really all we're doing is multiplying 4 times 3 times 2 times 1. And that's going to be equal to 24. So there's 24 different ways we can sit those 4 people up at the front of the stage. Let's take a look at number 2. So Mackenzie's setting up display of 7 most popular video games from the previous week. So she's setting them up in a row side by side. So let's set our 7 spots up. Okay, and how many different ways can she arrange them? So we're starting and we have 7 options when we are going to put up the first one. Then when we put up the first one, we have 6. And so really now we're just going to be multiplying all our way. Oops, I forgot 4. Apparently 4 doesn't exist in my world. I'm multiplying all the way down to 1. So I'm taking 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's going to be equal to 5,040 ways. So that's how many different ways we can arrange things on a shelf if there are 7 objects. Now let's take a look at this next part. So now we're setting up our display of the 7 most popular video games, but we can only display 5 of the 7. So now instead of having 7 spots, I only have 5. So when we start for the first one, we still have 7 options. For the next one, we still have 6, and then 5, and then 4, and then 3. But we don't have the last 2 spots because we're only putting up 5 of them. So we have 7 times 6 times 5 times 4 times 3. And when you multiply that, you get 2,520 different ways that you can arrange just those 5. Let's take a look at number 4. So for number 4, Zach and Brody are going to an amusement park. They cannot decide what order to ride the 9 roller coasters in the park. So the first part asks, how many different ways can they ride the roller coasters if they ride each one once? So for the first problem, we're assuming that they're riding all 9. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So when we first start, when we get to the amusement park, we have 9 choices for our roller coaster. And then we have 8, and then 7, and then 6, and then we're going to continue going down. Okay, so then you can multiply 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you do that, you get 362,880 ways that you can go on all 9 of those roller coasters at the amusement park. Now let's say, for example, now you only have time to ride 6. So now we only have time for 6 of our 9 roller coasters. When we start, though, we still have 9 choices, even though we're only riding on 6. We still have 7. Oops, 8, I lost 8 in there. And we have 7, and then 6, and then 5, and then 4. So we don't have time for the last 3 of them. Okay, so we're just going to do 9 times 8 times 7 times 6 times 5 times 4. And when you do that, you get 60,480 ways for that one. Next, let's go ahead and let's take a look at number 5. So, how many arrangements are there for the word triangle? So here's what I'm going to do first. Let's count how many letters are in the word triangle. So we have 1, 2, 3, 4, 5, 6, 7, 8 letters. Now I need to ask myself, are there any letters that repeat in the word triangle? And no, there's not. So then I have 8 spots. So when I start to pick up my first letter, I have 8 choices, and then I have 7 choices, and then 6, and then 5, and then we're going to go all the way down. So then in your calculator, you're going to multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you do that, you get 40,320 ways that you can rearrange the letters in triangle. All right, let's take a look at number 6. How many different arrangements are there for the letters in the word triangle if the first letter is an A? So we still are using all 8 letters, so I still have 8 spots. Okay, however, now we're saying the first letter has to be an A. Well, there's only one way that that first letter can be an A, so I'm going to write a 1 there. And then when we go to the second letter, since we've chosen this first letter to be A, then the second option we only have 7 choices. And then we're going to go down from there. So really, now that we said, okay, the first letter has to be A, we don't have that first one being 8, it's 1. So when we multiply in our calculator, it's really 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you multiply all of those together, you get 5,040 different ways that you can arrange the word triangle if the first word has to be, first letter has to be an A. Okay, let's take a look at 7. So how many different arrangements are there for the letters in the word triangle if the first letter has to be a constant? We don't care what the rest of the letters are, we just care about the first letter. So let's count the number of constants. So that's T, R, N, G, L. So there's 5 constants. So I'm still going to use all 8 of my letters, so I'm going to write all 8 of my spaces. So then I have 5 options for the first letter to be a constant. There's 5 constants, so there's 5 options there. Then when we go to the second letter, it doesn't matter what constant we've used 1 letter. So since we've used 1 letter, there's only 7 left for our second choice. And then 6, and then 5, and then 4, and then 3, and then 2, and then 1. So then in my calculator, I'm going to do 5 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you multiply that out, you get 25,200 ways. So that's your final answer for number 7. Let's take a look at number 8. In Minnesota, the license plates are made up of 6 characters, 3 letters, and 3 numbers. So how many different license plates can be made in the state of Minnesota? So let's do, here's our 3 letters, and here's our 3 numbers. So how many letters are there in the alphabet? Well, there's 26 letters in the alphabet. Now think about a license plate. Can you have a letter repeated? Absolutely you can. So that means that we're not going to take any letters away because we could have AAA or we can have CCC if we wanted to. We can have a whole bunch of letters that are the same. So that's why each of those options are 26. So now we need to figure out how many numbers there are. Most people assume that there is 9, but that's not counting 0. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are all of the numbers that we can use. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's actually 10 letters that you can use. Or numbers, I'm sorry. So then we can use the same number twice. You could have, 444 or something like that. So then each of these can be 10. So then in my calculator, what I'm going to do is I'm going to multiply 26 times 26 times 26 times 10 times 10 times 10. And when you multiply all of that out, you end up getting 17,576,000 different license plates that you can make. So that's why there's so many. I mean, we need that many, right? If you think about how many cars are in Minnesota, we need to have at least that many license plates. Okay? All right, next, let's take a look at number 9. So it says to review, so this is a review from Unit 4, and we're going to factor that. So for the first one, I notice that I only have an x in one of my terms. So for this one, the best I can do is take out a greatest common factor. So I need to figure out what divides 4 and 12, and that's going to be 4. So I'm going to take and I'm going to divide each of these by 4. 4 divided by 4 cancels out, and I'm left with x squared. 12 divided by 4 is 3. So then we have 4 times x squared plus 3. All right, let's take a look at number 10. So now we need to set up the x. So we're going to take 1 times 8, and that's going to give us 8. So we're multiplying to 8 and adding to 6. Well, what multiplies to 8 and adds to 6? That's going to be 4 and 2. So now I'm going to split up this 6x, and I'm going to put an x with each of those, so that I get x squared plus 4x plus 2x plus 6. So now I'm going to factor by grouping, and then we're going to take out an x, and then we have x plus 4. Oops, I'm sorry, this end number should be an 8. And then I'm going to take out a 2, and I'm going to have x plus 4. So then my leftovers are matching, so I can write my leftovers out, and then I'm going to write what's left after that. So this is fully factored form. You do not actually have to set each of the factors equal to 0 because it's an expression in number 10. It's not set equal to 0 itself. So that concludes your note for you today. Go ahead and show me your completed note sheet when you're done. Thanks for listening.